Hello everybody, welcome to CCNA Packet Tracer activity, which is 13.3.1. On this Packet Tracer activity, we will use ICMP to test and correct network connectivity. So without further ado, let's just get started. I'm just going to read the background that's given to us. So it says customers have been complaining that they can't reach some network resources. You have been asked to test connectivity in the network. You use ICMP to find out which resources are unreachable and the locations from which they can't be reached. Then you use trace to locate the point at which network connectivity is broken. Finally, you fix the errors that you find to restore connectivity to the network. So as you can see here, we have our corporate server right here, and we have our devices. So some of our customers are having problems accessing the corporate server. That's what's given to us on this lab. So we're going to be fixing that. So just one thing here, please don't be intimidated when you see a network that's a little bit bigger than what's usual in the packet tracer activity. No need to worry, we'll be able to finish this up in a few minutes, and all the, every command and everything we're going to be using for this lab is going to be simple, and there won't be anything so complex. So please stay with me until the end of the video. By the end of this video, you're going to be able to solve this problem, and you're going to be able to learn how to use trace RT command and the ping command. We're going to be able to also configure some of our routers IP addresses and our host devices IP addresses. So let's get started with PC1. So the first thing we do here is just use the ping command. We go here. So we're going to be using our addressing table because we're going to be pinging our corporate server's IP address. So as we can see here, PC1 have an IPv4 IP address, and our corporate server also has an IPv4 address here. So we're going to be using the IPv4 address of the corporate server. As you can see here, there's also an IPv6 address that we're going to be using for some of our devices. So because PC1 has an IPv4 address, we're going to be pinging the IPv4 address of the corporate server. So, which is, I'm just writing the IP address from here, 203.0.113.100. So we're pinging this. Let's wait for the result. So it says request timed out, but we see 304 packet has made it through. So I'm just going to double check. Sometimes your ping command might not work accordingly when you first try it. So just make sure you just try it a couple more times to make sure your ping is working or not. So over here we see that all of our 4 packet was able to make it through our corporate server. So that's a good thing. So that means our PC1 doesn't have any problem. So we're just going to go to laptop A, but before that, let's just mark PC1, so that we know it's working when we come back. So our PC1 works here. So how we're going to do this is, first we're going to find out which devices have problems here. And then once we find out which devices have problem, we're going to take a deeper look into those devices and try to configure them. But right now we're not going to fix anything. We're going to distinguish which device have problem and which ones work correctly. So as we can see here, our PC1 works good. So now we're just going to go to the next one, which is laptop A. So laptop A has the same IPv4 address. So we're going to be using our corporate server's IPv4. I'm just going to copy it, and we'll go to laptop A. We're going to go to the command prompt. I'm going to ping it. I'm going to write ping and then paste the IP address I got from here. Press enter. So we see that our ping has successfully made it. So that's good. So that means our laptop A is good to go. I'm just going to mark it. So that means we don't need to come back to laptop A because it's functioning correctly. So next it's going to be our PC2. We go to our command prompt, and as you can see here, PC2 have an IPv6 address, so we're going to be pinging the corporate server's IPv6 address. which is given to us right here. Also, we see it on the addressing table. So I'm going to be copying this and go to our PC2, write down the ping command, and then I'm going to paste it. So I'm going to paste it, press enter. So luckily, so our PC2 is also working good. So that's a good thing. As you can see, all of our packets have made it through to the network. So I'm gonna mark this again. PC2 is good to go. So now I'm gonna be jumping to PC3. So let's see if PC3 is working fine as well. I go to the command prompt, I use ping, and then I paste the IP address that I see here. As you can see, PC3 has also an IPv6 address, so I'm going to be pinging IPv6 address of the corporate server. I press enter. As you can see here, the packet has made it through, so we're good here. So I'm going to be marking PC3 as well. Mark it so that we know that we're not going to come back to PC3 because it's functioning well. So now that means our default gateway for this network is good. That's what it tells us from what we've done so far. So I'm going to go to PC4, go to the command prompt as usual. I'm going to be pinging the IPv4 address here of the corporate server because our PC4 has an IPv4 address, as you can see here. So I'm going to be using this address to ping. So I'm going to write down ping. Ping. Paste it. Paste this address. Press enter. Hopefully it's going to work, or maybe not. We'll find out soon. Okay, it says request timed out. Request timed out again. So it's probably not going to work. So we're just checking our PC4, as you can see here, PC4. All right, so the request is being timed out. Yeah, because we get 4 lost packets. We don't even need to do the ping command again. So I'm just gonna cancel this. I'm gonna mark it, and when we come back, because we will know this this device was not able to connect to our corporate server. I'm just gonna put a red mark on it, and then we go to our server 1 next. We do the same thing. Go to our command prompt, ping it. So server 1 has an IPv4 address, so just gonna put the corporate server's IPv4, press enter. We might find the same thing. Yep, we're finding that the request is being timed out. So on our RTR3, 2 of our devices are not functioning, are having connectivity issues, as we can see here. Yep, so all of our 4 packets didn't make it. So I'm just going to mark this as well. So let's mark this. Server 1 has a problem. And now we're going to go to PCB, laptop B, sorry. So we're going to go to laptop B. Laptop B, as you can see, have an IPv6 address. I'm going to be pinging the IPv6 address of the corporate server. I go to laptop B. I go to my command prompt. I'm going to ping the IPv6 address, paste it here, press enter. So yep, request is being timed out. So it's probably not going to work. Yep, we're having the same problem. Okay, so I'm just going to get ready to mark this as well. Yeah, all of our 4 packet has been dropped, as you can see here. So I mark it here. Laptop B is having problem. And finally, we're going to see if laptop C has any problem. So I'm going to be pinging the IPv6 address of the corporate server because we have an IPv6 address here. Press enter. And let's see what's going to happen. Yeah, our request is being timed out again. So that means we're going to be working on our 4 devices that we see here, which is connected to RTR3's default gateway. So we're gonna go to our next step, which is gonna be using the traceRT command to pinpoint on which uh, device our network is being broken. So our traceRT command is gonna be helping us to pinpoint on which device this command is failing. Right now we just know our connectivity is failing. We don't know where it's failing. So I'm just gonna do this here quick. Laptop C is now working. All right, so now let's go to the next step of fixing this. So again, I go to PC4, go to my command prompt. This time I'm gonna use the traceRT command to see. Oh, so instead of ping, I'm gonna use traceRT to see the network hops and on which hop our network is being dropped or failing. So here we see an asterisk mark. From that we can see it's failing on our first hop. So it says request timed out. So I'm just going to close this command and go to our next step, which is going to be checking our network configuration of PC4. Yes, I'm just going to close this command because it has already failed on the first network hop, which is going to be right here probably. But before checking the router, I'm just going to check if our network configuration is configured correctly. So sorry, I forgot to mention, I put ipconfig here to see the IPv4 address of our device, and we're going to try to match it with our addressing table IPv4 address and the subnet mask and as well as the default gateway. So PC4, we're seeing the network of this device right here. So I'm going to go to PC4. As you can see, PC4 has a network IPv4 address of 10.10.5.10. Over here we have 10.10.5.10, which is correct. As well, we're going to be seeing our subnet mask and our default gateway. So the subnet mask, we have 2.55.255.255.0, which is true here, 255.255.255.0. And now we have a default gateway of 10.10.5.1. Right here, our default gateway, it says 10.10.5.11. So it's clear here that our default gateway is configured improperly. So I'm just gonna cancel this, go to my IP configuration, and correct the issue here. So our default gateway, that's where the problem was occurring. So I'm just gonna correct it to 1. So now probably our PC4 is going to be able to reach our corporate server. So I'm just going to go here, go to my command prompt and see if it's going to be working now. Ping, or I just can use my previous command. So I just use the up arrow to go to the previous command that I've put it. So now because I've already put it, my ping 203.0.113.100, I was able to easily get that by using the up arrow. So right here you can see all of our 4 packets has passed. Again, I'm going to use my up arrow and go to my traceRT command to see if it's going to work. So this is the IPv4 address of my corporate server right here. Go to my PC4, press enter. As you can see here, our traceRT command has successfully went through. Before it was a big asterisk marks going on. Now everything has passed. So just to give you an idea, the first column in here, over here, so on our command, it just shows us the number of hops the route took to reach the destination, which is our corporate server. And the next 3 columns that you can see here, 1, 2, 3. So those show us the round trip, the round trip time each data packet took to reach each block and come back to the computer. So it just tells us the time it takes to go and come back to our network, to our device, which is our computer. So it says 0 microsecond, so which is good. Sometimes you can see a huge spike here in one of those hops. It might say over here on hop number C, it might say 200 or 300. So that will tell you that on our hop number 3, which is we're going to be counting 1, 2, 3, either here or maybe here, we're going to be having a problem that we're going to have to fix. So that's how the traceroute command works. So it helps you on which device your problem is occurring. And it also have like some other benefits compared to the ping command. It helps you to optimize network performance, as we talked about here. If we see a 300 microsecond time, a huge spike around on one of those hops, we can know that our network is having issue on one of our routers here. So that's one thing. And another thing is also it's good to, investigating security issues. It helps you identify the path of malicious packets, but that's not the scope of this video. So I'm just telling you, what traceRT command helps us to do. So right here, so our PC4 device is already fixed. I'm gonna mark it so that I know that it's fixed. All right, so PC4 is good to go. We have successfully figured out. So now I'm gonna be going to my server 1. I'm gonna go to command prompt, and then I'm gonna find out the IP config. I'm gonna write down IP config to find out if the IPv4 is done correctly. So right here I see an auto configuration IPv4 address. So that tells me it's not configured statically. It's actually given a DHCP network protocol. DHCP just means the dynamic host configuration protocol, which is a network protocol that's used to automatically assign IP addresses to devices on a network. So by just saying this, you can know that this address is not going to match with this because it's using DHCP, but our static server 1 address is 10.10.5.20, as you can see here. So we're going to be correcting that. Probably everything is not going to match our subnet mask and our default gateway. So I'm just going to get out of this IP configuration. I'm going to use, as you can see here, it's DHCP. I'm just going to be using static this time. So I'm going to be doing static, excuse me. So server 1, I'm just going to be looking this. So I'm just going to zoom out a little bit. All right, so that you guys can see everything, the default gateway and the IPv4 right here. So I'm going to go to my server 1 and put my IPv4 address, which is going to be 10.10.5.20. I'm just putting this address right here, which belongs to my server 1. I go to subnet mask. I put 255.255.255.0, and then I put my default gateway, which is 10.10.5.1. All right, so probably good to go. So gonna click X here. I'm gonna use my command prompt to ping and see if we are successful this time. Yep, we're successful. So we can see our server 1 has been able to go to our corporate servers network, has been able to reach it. All of our 4 packets have successfully made it through. That's a good thing. I'm just going to use my traceRT command to double check. So over here, I'm just going to, instead of ping, I'm going to write down traceRT, press enter. As you can see here, all of our 4 hops right here have made it through with just so little microsecond time to go to our corporate server. Actually, over here, one thing I forgot to mention is on our traceRT command, these are the IP address that the hop have. So when you go to our TR3, this is going to be the IP address, and then when you go to RTR1, it's going to be the IP address. So it just tells you the IP address of the hops that it crosses, so that it goes across with. So that's going to be that, and we're going to go to our laptop B. So we're able to configure server 1. So we're almost getting done here. So please stick with me just for a few more minutes. So server 1 is good to go now. So as you can see here, if you go to your packet tracer activity completion, we've already have done 71% of it. So we're getting done. So now we'll go to our laptop B this time. I first do the trace RT command to see if that's going to be working correctly. Just going to zoom in again. And then as you can see here, it's an IPv6 address. Or, I can just use the up arrow and go to my ping command that I've done previously, and I use the trace RT command, press enter. I'm probably going to have I'm not going to get any network connectivity. Yep. So right here we see an asterisk mark that tells us that it's not communicating. So I'm going to get a request timed out result probably. Yep. So I'm just going to stop this command and try to see the address configuration of our laptop B. So I'm going to be comparing it with my addressing table again. This is our laptop B. I'm just going to highlight it here. So this is our laptop B. Go here. Actually, one more thing, you don't even have to use the command prompt to see the network configuration. You can just go to your IP configuration here. And then as you can see here, our IPv6 address, oh, it's matching here. So 201 DB8 5.10, and we have a /64 subnet mask. And probably our default gateway is FE01. So over here, everything looks good. So that tells me that our problem is going to be here, our RTR3 configuration. So I'm going to go to my router, press enter here, and I'm going to write down enable to go to the privilege mode. As you can see here, it's the pound sign tells you that it's on privilege mode. And then I can do the command show run, or you can put show running configuration. It's the same thing. So you can see our hostname RTR3, but we need to see the over here just quickly. We're going to be looking our RT3's G000 interface and G001 interface to see if everything is working correctly. This is the two addresses that we're going to be seeing. So I'm going to go back to my laptop, not laptop B, excuse me, it's going to be RTR3. So I'm going to go here. So my IPv4 address, which is 10.10.5.1, as you can see here, that's correct. And now when you go to subnet mask, you see that it's 255.255.255.0, which is also correct. When you go to the gigabit interface 0/0/1, you can see that we have an IPv6 address of 2001.db8.6.1/64. But as you can see here, our address doesn't match with our addressing table. It says here 201.db8.5.1. So over here we have 0.6.1. So that's probably where our problem is. So we need to go to the gigabit Ethernet 0/0/1 interface to fix this issue. So I'm gonna go here. I'm gonna do my configuration terminal, config T or configuration terminal, the same thing. So I'm gonna go to interface. I'm gonna write down interface. So you can't do this. If you have watched my previous videos, you would know that you can't configure interfaces when you're in privilege mode. You have to go to the configuration terminal. So that's why I went to my configuration terminal. I write down interface, and then my interface is G/0/0/1. Sorry, I forgot a 0 here, right here. All right, so I'm going to this interface. Oops, I just did an extra 0. So I'm just going to this interface, G0/0/1. I press enter, and now I'm at the interface. So first we need to remove the misconfigured IPv6 address, which is gonna be this one right here. So just gonna, let's see if I can copy it. Oh, it's not gonna allow me to copy it, so I'm just gonna go back and see 201.db8. Over here I write down first we have to do no IPv6 address, and then I'm gonna have to put I'm gonna have to specify which IPv6 address to remove. So 201.db8.6, sure is 0.1.100 if I'm not mistaken. Let's see, 0.6.1. Sorry. So 0.1/64. So I'm just gonna remove the address that's right here, the address that I'm seeing here. We have to remove that in order to put the new address. So I write down no IPv6 address, and then write down the IPv6 address that I need to get removed. Press enter. So now it's successfully removed. Now I'm gonna have to put the new IPv6 address. So I'm gonna write down IPv6 address. So I'm gonna have to put this IPv6 address, which is gonna be 201.db8.5.1 column 1, and then I'm gonna put my /64. This is my subnet mask. I press enter. Now I have successfully configured it. So always you have to put the no shutdown command, and now I can exit. Now everything should be working. Oh, by the way, as you can see here, our packet tracer activity is showing us 100%. That means we have done everything correctly. But please stick with me for a couple more minutes, and I'm just going to finish up, just show you how everything's going to be connecting. So I go back to my laptop B, go to my command prompt. I go to ping, and I'm going to be pinging our corporate server again. Let's see if it's going to work. Sometimes the first time we use ping, it doesn't work. We have to double check it. When it's only one packet that has been timed out, we have to probably do it again. Oh, so unfortunately we're having issues again. Our ping is being unsuccessful. So just one thing we forgot to do is we had to shut down the router and start it back up again. So good thing I'm on my configuration terminal. I should put the shutdown command. So this is gonna shut down our router's IPv4 address. So I have to go to my interface first. Interface G0/0/1. That's the interface we just configured correctly. And then I'm gonna have to shut down that address. So now it's, as you can see here, changed state is down. So I'm gonna press enter again. Now I'm gonna have to start it back up. No shutdown command. Press enter. Now it says change state to up. So now it tells us our interface is up. I will exit and exit again. Now we're on our privilege mode. So we put X here, laptop B, come back, and then ping it again. So this time it should work. Let's see. Unless we have missed a step. So the first ping didn't work. Just wait for it a little bit and see. Okay, it's timing out again. Oh, but we see here we have 2 packets that has been received. So we're gonna do the ping again. So if your ping shows you that all 4 packets have not been lost, that means you have to do the ping again to just make sure your ping, is working or not. So right here now our 4 packets have been able to go to our corporate server with 14 milliseconds of time on average. So now I'm going to go to my traceRT command and see the same thing. Okay, so as you can see here, it works good. So we've seen that all of our 4 hops have were able to communicate. So we're done with laptop B. We're just left with laptop C, which I assume is going to work because we have already solved the problem which was underlying on our router. But just to be sure, we're also going to check the IP configuration of this router. So as you can see here, our IPv6 address is 00. So right here, our IPv6, this is our link local address. So our IPv6 address is 2001 db85/20. So let's see here. So laptop C, this is going to be the addressing table that we're going to be looking at. So I'm going to do here. But as I told you before, you can also look it right here on your IP configuration. You go to static. So IPv6 address, you can match it db85/20/64 and our default gateway, which is FE80.1, which is right here. So everything looks good here. Put X here. So on the command prompt, it just shows you the same thing. You have your IPv6 address with this address, and we're gonna also see our default gateway right here. So if I put the ping command, it should work now because the problem with this PC was the router. Everything the network configuration was good, but we just have a problem with our router configuration. So as you can see, it has worked. I'm going to use the traceRT command to see if that also works. I'm gonna put traceRT, press enter. Okay, so everything has already passed. So that concludes our video. We have configured our our gigabit interface G/0/1, and also we were able to configure our host devices network configuration. So now we were able to reach our corporate server by configuring these addresses. So by now our customers here should be happy. It says previously they were not able to use a corporate server, but now every device reached a corporate server. So if you have any questions, please feel free to put a comment below and I will make sure to answer it. Also, if there's any packet tracer activity that you're struggling with, please put it in the comment below and I'll make sure to put a video on it. Thanks everybody for being here. Until next time. Bye.